So welcome everybody that's online with us today. This is a short webinar on mainly focusing on plastic pellets and how to capture them on your commercial facilities. This webinar has been set up through a collaboration with the Alberta Plastics Recycling Association, and we've got Stacey who will be giving us a brief introduction as to what APRA has been doing. Following that, I'll discuss, I'm from EnviroPod, my name is Darren, I'll be hosting and emceeing this session. I'll be talking a little bit about some of our technologies and how we use them to capture plastic pellets and prevent them from escaping into the environment. Next, we'll be joined by Neil Menzies from EcoCompass. Neil will be talking about some of the Operation Clean Sweep initiatives that are going on in Canada, as well as some of the trials of the product in terms of its performance with capturing plastic pellets. And then we'll close off with a short discussion from Nicole Newton. She's from the city of Calgary, where she'll be discussing some of the application process for installing LittaTraps in Calgary. I understand we've got a few people from Edmonton, and the process would be quite similar with your local authority there. So Stacey, if you want to just kick things off.
Yeah, for sure. Thank you so much. So welcome everyone. I'm Stacey from the Alberta Plastics Recycling Association, a not-for-profit that's been around since 1991. Our members are from companies throughout the plastic value chain who continue to seek knowledge and business opportunities in resolving plastic waste issues. Now, before I turn the presentation over, I just want to give some background as to why we are here today. So Calgary has experienced some plastic pellet releases in waterways in 2016, 2017, and a more significant release impacting Chestermere, a city east of Calgary, in 2019. The city of Calgary and APRA collaborated together to find where the pellets were coming from, and what we identified is that release did not come from a single company. APRA has been supporting companies to collaborate, develop best management practices, and adopt Operation Clean Sweep principles to improve plastic management for some time. We know that bringing the community together to share resources to improve plastic pellet management is a key. And so today's webinar showcases the LittaTrap, which is just one tool in the toolbox for plastic management. I'd like to thank Nicole, Graham, and others from the City of Calgary for their ongoing direction and support. The information shared today will help companies to implement changes within their businesses, and APRA will continue working with you to bring opportunities forward for plastic management.
Thank you very much, Stacey. So just quickly touching on some just house rules for this session. If everyone can please keep their microphones muted. You're welcome to write questions in the chat pane, or we will take some questions towards the end. All right. So this is what we're here about. We're going to be talking about plastic pollution in stormwater. So just to give you a quick overview, the company that is presenting this, EnviroPod, is a company that has been operating in stormwater technologies for more than 25 years. And we've got a huge amount of experience across North America as well as in Asia Pacific. And I'm talking to you today from New Zealand, where it is currently raining. So it's a good industry to be in. We've been focusing a lot of our research on plastic pollution over the last 5 years. And some of the results and some of the learnings from that research is going to be presented here today, with a big focus on microplastics. As you can see on the right-hand side, we've got macroplastics above 5 millimeters, and then on the left-hand side image, we've got microplastics. And one of the most common microplastics is certainly plastic nurdles or resin pellets. And these are used as a primary input to plastics manufacturing, and they are very easy to spill during transportation, material handling, and once they get into the environment, they're very difficult to capture because they're quite buoyant. They move very easily with water and even with wind. So we're going to show you some source control and how to capture plastic pellets at source. It's important to understand, though, that the technology that we're going to show has multiple applications. So for plastic pellets, it's just one application, but it can be used, for example, across a city. And we've got a big project now with the city of Barrie to capture coarser plastics or gross pollutants, mainly cigarette butts and food wrappers and the sorts. All right, so today we're really focusing on this 1 to 5 millimeter range, and in academic literature, this is often referred to as large microplastics. When you get down to small microplastics and nanoplastics, these become a little bit more in the domain of wastewater, whereas stormwater is very much from 1 millimeter and larger. All right, to give you an overview of the LittaTrap technology that we're going to show you today, it's a catch basin insert. It's easily retrofit into new or existing stormwater catch basins. From the graphic on the left-hand side, you can see how it is installed within a catch basin. It's a very quick and easy process to install. The modular components allow it to be flexible within any catch basin design. We have a bracket frame that's installed with plastic seals and a LittaTrap basket that is easily removed from the catch basin for maintenance purposes. Right, an innovative technology that's very easily installed by any plumber or contractor. And some of the overview of the product and its benefits are that, first and foremost, it stops plastic from leaving your site. It can also help reduce costs because it reduces the risks of any stormwater blockages from gross pollutants. It captures these pollutants and keeps them dry. It has a minimal maintenance cost. You can maintain a unit within a few seconds by hand and dispose of that rubbish where it belongs in the rubbish bin, or even recycling. As I said earlier, it's easy to retrofit, and there's also a large amount of energy dissipation of the water going into the catch basin. And this means that it often increases the capture of other pollutants such as sediment, some particulate metals, and nutrients. All right, just a quick short video on maintenance. So maintenance can be done by hand, as I mentioned, and this is just a pure lift, tip, and replace the basket. So you can see all the contaminants that were captured have been put back into the rubbish bin where they belong, and then the LittaTrap goes on. Maintenance cycles are usually 2 to 3 times per year, depending on the loading. It can be up to 4 times a year, so that's basically once every quarter. It really depends on the loading that is present at your site. Just want to show you a few examples of case studies that we've done. Obviously, a huge component of plastic pollution and the solutions that are to come are mainly through education. Education is a very effective measure, but it is not the only measure, and it cannot achieve 100% of compliance or pollution reduction. So we are very engaged with school programs as well as academic programs at universities. It is a critical component. We've also installed across a range of facilities, and I know some of the attendees of this webinar are not just from plastics manufacturing. There are some people that are involved in logistics, or if you have a logistics component within your business, this is often a point source for litter pollution. Retail shops, this is more on the public facing side. Retail, there is often large amounts of plastic pollution generated from these sort of facilities, but also behind retail facilities, there are often loading and unloading zones, and this is certainly what's called a hotspot in litter pollution. Just a few more examples of case studies. Manufacturing facilities, and specifically plastics manufacturing facilities, is the origin of a lot of this discussion. We've also worked with some good brands. Toyota has a very good global program to reduce the amount of plastic pollution that comes off of their sites. All right, so just to quickly give you an overview, a lot of you may have existing treatment facilities. You might have some stormwater treatment facilities underground, or maybe rain gardens. So there's this concept within stormwater management of pre-treatment. Pre-treatment can be a very effective means of reducing maintenance cost of downstream treatment. As I mentioned, manufacturing facilities and retail facilities. Industrial stormwater is always a challenge, and capturing gross pollutants, capturing microplastics is always going to be something that can be done very early in the treatment process. So something right at the top of the pipe, so as close to the source as possible. And this is effective at reducing the breakdown of plastics as they get transported through the stormwater reticulation network. And then at the bottom, you've got a lot of public areas where you have a lot of foot traffic, and these are always going to generate lots of plastic pollution loads. Okay, to just quickly focus on commercial and industrial areas. So our research and a lot of global best practice really focuses on both the transportation and the manufacturing process of plastics. So there's a lot of transportation of plastic resin pellets before they actually get to the facility, and it's usually these material handling processes where plastic resin pellets have the opportunity to escape and enter into the environment. So first of all, if you look at any transportation activities, so you've got loading zones in and out of trucks, or even in and out of trains. There's a lot of resin pellets that are transported by train networks, and they're usually moved from one vessel to another through vacuum pumps. And a lot of our facilities have rubbish bins or rubbish collection areas. And these are also particular hotspots. We've all seen a rubbish bin that's been blown over by the wind and all of its content strewn on the ground. This is often just an accident. And if you have a protecting piece of equipment in the drain nearby, such as the LittaTrap, then you can rest assured that all that plastic pollution then does not enter the environment. So not all spills are intentional. There are many that are accidental, and that's exactly what the LittaTrap's designed to do, is to be that last point of protection before any plastic pollution enters the piping network. The piping networks are designed to transport water and pollution very efficiently to the nearest water source. Okay, so just to quickly recap on that, when you're looking at commercial and industrial zones, you're really looking for waste storage or waste handling areas, and also loading zones. These are going to be the locations where plastic pollution has its highest likelihood of escaping into the environment. Okay, I've got many hundreds of photographs like this on the right-hand side of plastic resin pellets filling up LittaTraps. And I think the majority of people have seen or know what these resin pellets look like, sort of 2 to 5 millimeters in size. So they are smaller than 5 millimeters, so they don't fit within the world of gross pollutants. So what we use in the LittaTrap is a 1 millimeter or a 1000 micron liner. And we also have a feature within the LittaTrap where we have a bypass where water is able to flow through the unit in the event that the unit becomes full of pollution. What we end up doing with plastic pellets is we prefer to close that bypass. And what that means is that we can ensure the full capture of pellets. So we increase the capture efficiency, because a lot of resin pellets are close to a density of 1. So with any kind of movement of water, they will actively float. What this means for a facility is that you're removing one layer of safety when it comes to water flow. So what is required then is a more strict maintenance regime. The benefits of doing it this way is that you provide a very high level of compliance and a high level of plastic capture. But it does mean you need to inspect and maintain these units on a bit of a more regular basis. A lot of companies have a 1-month inspection process, which is good. I would highly recommend any commercial facility have at least a 1-month inspection of all critical safety features such as pollution prevention, but also things like fire safety and so on. We do have a few companies that do it on a weekly basis, which is even more proactive and certainly going towards best practice. Just to mention though, it's not only plastic manufacturing facilities that can benefit from capturing their pollution. Any manufacturing can fit within that, as well as transportation hubs and any commercial sites that generate, for example, plastic shavings from cutting. We have a customer who cuts plastic piping, and that generates a lot of very small cuttings and shavings, and they do vacuum and sweep, which is great. That reduces the load significantly, but there will always be a portion of those cuttings and shavings that cannot be controlled using what are called non-structural measures, such as sweeping. So we've worked with this customer to provide a LittaTrap solution to capture that sort of last %. Okay, I mentioned there are these performance liners. So across North America, we offer 3 types. 5mm is what's termed a gross pollutant liner. Sorry, I think my signal just dropped off there. Can everyone still hear me?
Yep.
Okay.
Yep, we can hear you.
Sorry.
Yes.
Okay, so I was mentioning the state of California. So they have a program where they're looking to install catch basin inserts to capture gross pollutants, so everything over 5mm. And this is a very effective policy that they're implementing. They started in 2015, and they're looking to have basically 0 plastic waste entering the stormwater network within 15 years. So it's quite an ambitious target. We use the gross pollutant liner in public sites across Canada, as well as we're working with some big retail industries to try and get them to put these particularly in their loading zones. So if you're on a public site and you're concerned about coarse plastic materials, the standard LittaTrap with 5mm mesh liners will be more than sufficient. If you've got plastic pellets or micro pollution on your site, then you're looking at the 1mm liner, or even finer than that is the 200 micron liner. So based on the type of pollution that your site generates, you've got a range here of 3 liners. They bring with them benefits in terms of some capture more or finer material, but then the trade-off is the more you capture, the more you must maintain. So this gives the flexibility to a facility to utilize the technology to best suit their site and their maintenance regime. Just a quick word on the liner installation. So this is an add-on feature or an accessory, if you like. It's very easy to install the liner, and it's very easy to change them out. So if there is any sort of long-term wear and tear, the liners are designed to last a long time. But if you do have very high pollution loading and things like, very sharp pollution or whatever the case is, these are relatively cheap accessories that you can swap out over time. The LittaTrap design is quite novel, and there are components that can be added or removed. So it makes the product highly durable, but in the case of having to replace parts, that's an easy and cheap process. We do back the LittaTrap with an 8-year warranty on the static parts. So that's basically everything besides for the basket itself. Just a quick mention on sampling methods. On the left-hand side, I've got a photograph of a old stainless steel grate that was put into a recycling facility. You can see the pollution loading on the left is incredibly high. And this is at a recycling facility, which is supposed to be somewhere that captures plastic and puts them back into the economy for reuse. Unfortunately, a lot of recycling facilities are massive hotspots for plastic pollution. So that's definitely something that has been a target for us. And we've worked with a lot of recyclers across the world to try and improve their environmental footprints overall, because the work that they're doing already is saving plastics from going into landfills, but we also want to save plastic from going into the environment as well. The 4 pictures on the right is a case study and a draft publication that we're working with the University of Toronto, as well as Neil Menzies, who you'll hear from next, on aspects of Operation Clean Sweep relating to compliance and subsampling. There's a lot of people that are looking to gather data on how much plastic pollution is going off of certain facilities, and if you introduce some of the, for example, Operation Clean Sweep best practices, how much are we reducing the load of plastic entering the environment? So we've developed a bit of a sampling methodology that makes counting many thousands of pellets a relatively quick and easy process. So we capture pellets using the LittaTrap with the 1mm liner. We do a combination of buoyancy and screening separations. And then we use a subsampling method to estimate with a fairly high degree of accuracy the number of plastic pellets. So Neil will present some of the data, but as you can see from both the picture on the left and the picture on the right, the number of plastic pellets that are being captured in LittaTraps is in the hundreds of thousands, if not more. So that's just, I like this slide because these resin pellets on the right-hand side were supposed to be for production. They were spilled or escaped from the process. They never even became their final product. And then on the left-hand side, we've had lots of different bits of plastic through this recycling facility. They do break up, and you can see this is sort of the beginning of their life on the right-hand side and the end of their life on the left. And in both cases, neither one is welcome in the environment, very much welcome in plastic products such as syringes for COVID vaccines, but certainly not down the drain. I'm going to skip over Operation Clean Sweep because Neil will provide some detail there. I just wanted to give you an overview though on Operation Clean Sweep is a global initiative, and we are working with plastics manufacturers across the continent from down in Texas. You can see the size of their drains. There's a common joke in Texas that they have no rain, and then they have a hurricane. So you can see incredibly large catch basins with very large LittaTraps capturing a lot of plastic pollution. And we can definitely sympathize with people down in the Gulf area now as a hurricane does actually pass through there. Just a quick mention on the actual liner maintenance. So a LittaTrap without a liner is easy to maintain. If you do have a liner installed though, it's the same procedure. We just encourage at least a rinse once a year of that 1 millimeter liner. It does not blind very easily with debris, but any kind of cleaning of that liner will just help with the hydraulic flow, because as much as pollution capture is important, as is the flow of water, obviously that water needs to move out and off that drain and off of that site. Okay, I've got a few notes from the City of Calgary. I will let Nicole talk to this at the end of this webinar. I just want to mention though quickly, if any facilities are looking to install LittaTraps, we have a sales agent who's based in the USA, Will Harris. He's on this call. We will provide his contact details for anybody looking to install LittaTraps on some of their facilities or with any further questions. Okay, but in the meantime, over to Neil.
Thanks, Darren. Let me share. Okay, can you see my screen?
Yep.
Okay, perfect. Well, thanks for having me. So, as Darren mentioned, my name is Neil Menezes. I'm the president at EcoCompass Inc. And I'll be talking today to you about a little bit about Operation Clean Sweep, which has been referenced quite a few times in terms of in Darren's presentation, and then also one of the pilot projects that we undertook late last year to test the effectiveness of the LittaTrap in preventing plastic resin from entering into the environment. So in terms of a little bit about me, I've been in this industry for about 10 years, supporting a broad range of companies in the environmental and sustainability fields. And part of the project I work on, they typically focus on waste diversion programs, and that ranges from recycling to other materials. And to determine the effectiveness of these programs, I do a lot of the data analytics and identifying strategic partnerships to bring together different stakeholders, as you know, especially now with environmental issues being top of mind for a lot of different companies, the governments, the public, and the ability to bring different stakeholders together to help understand and work towards a solution together. So in terms of the organizations I work with, and it's been a broad range of municipal clients, especially here in Ontario, but also doing a lot of work with brand owners and other associations, including the Canadian Plastic Industry Association and the Chemistry Industry Association of Canada. Right now, in my current capacity, I'm supporting the sustainability consultant on the Operation Clean Sweep program that's being run by CIAC. And what I'm going to do is provide you a little bit of overview of the Operation Clean Sweep program here, specifically in Canada, because it is an international program. And those of you who are in the US will be familiar with the program that's being run by ACC. And if anyone's on the call from Europe, there's also Plastics Europe that's running the Operation Clean Sweep program. So what I'll do is focus primarily on how the program is being run here in Canada, but happy to answer any questions related to that program and also generally how it may apply to you. So a little bit about Operation Clean Sweep program in Canada. It is similar to the program globally. It is a prevention-focused pellet stewardship program with the goal of achieving zero plastic resin loss into the environment, especially into waterways. And the focus, because it's so preventative focus, it's not designed to necessarily require significant investment, but it's a matter of improving and implementing good housekeeping practices and procedures at the site level. And the whole idea is to make sure that plastic resin doesn't leave your facility, fully recognizing there are multiple pathways for the materials to escape a production facility or even including recycling facilities. And one of the key things what we wanted to do with the system or with this program is to make sure it's sustainable. It's something that we want companies to implement into their regular management systems and part of their company culture. Even though this program is kind of presented as Operation Clean Sweep, and it has its own, we're standing from that perspective. The idea is we want it to be integrated into everyday operations, because to achieve that zero plastic resin loss goal, it requires a day-to-day implementation of these operations. And for anyone that's a CIAC Plastic Division member, there is a commitment to have all members implementing this program by the end of 2022. So this kind of goes to the fact that the program is evolving a little bit in terms of how it's being implemented here in Canada, and now it's becoming a requirement for members to actually implement this program, because we want to demonstrate the industry's leadership in providing environmental stewardship and proper management of plastic resin to ensure it doesn't end up into the environment. So the program has 3 simple guiding principles. As I mentioned earlier, the main first focus is the preventive focus, and the ability to prevent the plastic resin before entering the environment by implementing good housekeeping practices and updates to your procedures is going to be critical in that success. The second guiding principle is accountability, and part of the accountability is to get more information, more involvement from the member companies to share their experiences in terms of how plastic resin is being managed at their sites and potential issues that may have arisen as your operations evolve. We recognize plastics is a primary focus and is highly valuable for the economy in terms of providing goods to consumers. So what we're trying to do is collect a little bit more information in how the members are managing the plastic resin, so we can support in sharing best practices for preventing plastic resin entering the environment. And the third most critical step is this continuous improvement. So it ties back to the accountability in terms of getting a little bit more information from the member companies in issues that arise from managing plastic resin, but we're also looking at best practices that companies have implemented that are successful. And part of that is conducting pilot projects, which I'll talk a little bit later in my presentation in terms of a pilot project we conducted here in Ontario with one of the member companies. So in terms of supporting member companies, we have prepared an OCS toolkit, and the toolkit is designed to provide you all the necessary steps to help understand what are those best practices for managing plastic resin at your facility, and also to provide you with two critical components in tracking potential plastic spill incidents and issues that may be visible or occurring at your site, and have ability to track this information on a regular basis, ideally quarterly, to determine whether these issues are improving or another corrective action is required to manage these potential issues. So there's a site assessment booklet which allows you to conduct an assessment at your facility, and then a site issues tracker which is designed to take the information from your site assessment and track it on a quarterly basis. So you will see a trend in terms of where the hotspot areas that may need additional focus, or even potentially, if you wanted to reach out to, either APRA or CIAC in terms of supporting and understanding what are some of those preventative measures that can be taken, or potentially cleanup solutions that can be taken. It just gives you an opportunity to identify those opportunities and then implement those solutions over time. There's also an employee training presentation. We recognize every member company is going to be slightly different in their operation. So there's an employee training presentation that allows you to customize it to your specific procedures and handling of plastic resin, so your staff knows where to find specific tools and resources to prevent plastic resin loss and potentially implement the cleanup solutions. The fifth one, which is the signage, is something we're still working on with the members to identify what's the appropriate signage and where do they need to be placed to remind staff of the appropriate procedures to manage plastic resin and how to clean up any potential spills. All of this information is available on the CIAC website at opcleansweep.ca. So as I mentioned, one of the primary focus of the program is part of collecting data and improving the procedures in managing plastic resin. And what we did is we partnered with the University of Toronto the Ontario Ministry of Environment, Conservation and Parks, MECP, and at the time of CPIA, but CPIA, which transitioned over to CIAC, to undertake a pilot project, one of the member companies, to understand how plastic resin was being managed at the facility. The initial program, what was called Operation Sweep the Creek, looked at an area called Mimico Creek, which is just in the west part of Toronto, and into Peel region, flowing through Mississauga and Brampton. At the time, University of Toronto was studying the plastic resin found within Mimico Creek, and there was a clear indication that during dry events, there was a fairly small amount of plastic resin found within the creek, but during rain events or large rain events, there was a significant amount of plastic pellets and fragments found within the creek. So as part of this program, working with the UFT and identifying the member companies that manage plastic resin within this watershed, I reached out to these companies to provide them a little bit more information and insight in terms of the best practices of managing plastic resin and how to prevent plastic resin from entering into the creek. There was one member company that was really engaged in this process and really wanted to take it to the next step, so invited us to their facility to help assess opportunities for them to avoid plastic resin from entering the environment. So the company had undertaken some initial initiatives by sealing, so I won't go through all of the initiatives, but they went through some initial practices to prevent that plastic resin from leaving their facility and entering into the environment. They did daily sweeps of their site area, both within and outside the area. They placed appropriate catchment systems below their silo connection points, their railcar connection points, and they also looked at implementing regular vacuuming of the outdoor areas with shop vacs and identifying different solutions for all of the different areas where plastic resin was being handled and potentially being lost into the environment. So this is just a list of some of the existing initiatives that they had undertaken to prevent plastic resin from leaving their facility. However, with all of those initiatives being undertaken, there was still some plastic resin that was visible around their facility. And one of the key things we noticed during the site visit was they did not have any screens on their storm drains. So looking at the potential opportunity for a large rainfall or storm event where the plastic resin could get dislodged from the rail track here and potentially flow into the storm drains, we saw an opportunity to work with EnviroPod to install the LittaTrap to test its capability of preventing the plastic from entering into the storm drains. So in discussion with EnviroPod, recognizing they're a New Zealand-based company, what we want to do is really test the effectiveness in the Canadian environment. Recognizing we have 4 distinct seasons, we recognize that with the snowfall and also our fall season where a lot of the leaves could potentially jam the system, we really wanted to stress test the LittaTraps to see how effective they would be in preventing plastic resin from entering the environment, but also how frequently did they need to be serviced to prevent potential flooding situations. So as Darren mentioned, we installed 2 initial LittaTraps for this pilot. We aligned them with the pellet liner, the 1 millimeter size screen. And the one thing we made sure was to remove the bypass openings for the LittaTraps. Obviously, we didn't want anything escaping the system. So we worked with EnviroPod to make sure those were sealed, to fully test the capabilities and stress test this LittaTrap to make sure it didn't cause any flooding issues, given the fact that the LittaTraps were installed in December 2019, and we knew with the snow that would come, it would be a good test to see how it can manage the melt that will occur once we enter into the spring season. So in terms of the installation of the LittaTraps, after we installed the first 2, the company had contacted EnviroPod, given its initial success, and clearly there was no indication of flooding that had occurred. They installed additional additional litter traps in the remaining storm drains. So this facility had 6 in total. 2 of them were installed with a litter trap. There were an additional 3 that were in high traffic or production areas where there was potential for plastic resin to potentially lose or be spilled through the storm drains, and then installed litter traps in the remaining storm drains. And I believe there was a 6th one, which was in more the parking lot area, and I think eventually they installed one there just to be safe in terms of if any plastic resin made it over to that storm drain, and they covered all of the storm drains on their site. So not only did we install the litter traps, we wanted to measure the effectiveness and measure the amount of plastic resin that was being trapped or prevented from being entering into the environment by using these litter traps. Working with EnviroPod, again, this was in the midst of the pandemic. We were still able to service them on 3 different periods, and you can see there were some gaps between when we had to collect them, primarily driven by the lockdowns that the Ontario was going through. So, the first collection was about a 35-day span in terms of when the materials were serviced last. The second one ranged from 82 days from that first collection point, and then the third collection point ranged from about 34 days. So you can see there's a bit of a variance in terms of how frequently these litter traps were serviced. And what was clear in the event, because of the effectiveness the company had implemented in preventing plastic resin loss in the initial point, we don't have any of those pictures that Darren kind of showed with a high degree of plastic resin being diverted in the litter traps, but you can clearly see there are some visible litter traps embedded in all of the other dirt and debris trapped in the litter traps. So for each litter trap, we identified the depth in terms of the loading that had occurred, the type of contaminants visibly in terms of, here we see
Sorry, Neil, I think your microphone just muted. That was strange. Oh, thanks.
Sorry, can you hear me now?
Yes, got you.
Okay, perfect. So working with UFT, we wanted to quantify the amount of plastic resin loss that was being prevented using the litter trap. So Darren had talked about the sampling methodology, which was developed in partnership, which was relied heavily on the CBIN project by the Rockman Lab from UFT. And we quantified the amount of pellets, foam, and hard fragments found within the 5 different litter traps that were installed at the site. So here's a picture that kind of identifies the starting point of all the materials, including the debris and the plastic resin all together. Here we had the ability to kind of zoom in and identify the separate, here's a pellet, a random plastic fragment, and then some foam that was found in this, in the sample. And then we really zoomed in down to quantify the amount of individual plastic fragments, pellets, and foams that were found in the litter traps. Again, we relied on a sampling methodology, recognizing counting each one of these pellets would take forever and probably not the most effective use of everyone's time. So it's a way of finding that balance of trying to quantify how much plastic resin is being diverted, but also trying to develop a sampling methodology to make this a more practical approach. So as we talk about the effectiveness of different initiatives, we have an ability to identify, quantify the amount being diverted as we start planning in terms of what are the next steps and what are the next best practices to be implemented to get to us to that 0 plastic resin loss into the environment. So out of the 5 litter traps installed, we clearly see certain LittaTraps had greater degree of plastic resin being found within it. In total, based on our estimate in terms of the count, we counted about 60,000 pieces of plastic resin that would have been potentially entering the environment if this facility did not install the 5 LittaTraps. Now, recognizing the 60,000 pieces sounds like a lot of plastic resin entering the environment, but recognizing these facilities handle rail cars full, and recognize your facility may even handle significantly larger volumes of plastic resin, the total amount by weight was estimated to be about 1.2 kilograms. So in terms of overall weight probably being managed versus what was leaving the facility, we recognize it's a small amount, but this is where preventative measures are critical in reducing what could be lost, and then the LittaTrap becomes an effective tool to make sure it becomes that final parachute, that backstop to ensure that it's impossible to capture everything in your day-to-day operations, but the LittaTrap was proven to be an effective tool in terms of preventing whatever small amounts were still being lost after all of the preventative measures. And recognizing that because it's a large facility, or this facility was relatively small compared to some of the other facilities obviously out there, with only 5 storm drains on site, it's clearly critical to install LittaTraps in where there is offloading or unloading of plastic resin. So we see large, surprisingly, we saw a greater amount of plastic resin by the storm drain close to the truck connection point rather than the rail car connection point, where it seemed it was more visible. Plastic resin was a little bit more visible on the rail tracks, but in terms of what the results showed, it was more around where the truck connection points were that we saw a large amount of plastic resin entering into the storm drain, but fortunately being prevented in entering the environment because of the LittaTrap. So this kind of leads to some of the questions. You know, one of the observation and potential issues to consider is whether your area is paved or unpaved. Obviously, in the rail car area, it's a little bit. Parts of it were paved, but also parts of it were unpaved, which is, in terms of the paved area, it makes it easier to potentially clean up the plastic resin, but it also makes it easier for the plastic resin to run off your site. So if these paved areas are graded towards the storm drains, it becomes critical to install the LittaTraps to prevent them from entering into the storm system. The unpaved areas obviously trap the plastic resin because given its light nature, it doesn't dislodge as easily, but obviously makes cleanup a little bit more difficult in terms of overall site. So these are some of the key considerations, and then helping you understand that the LittaTrap is an effective tool in as almost your last line of defense to make sure that plastic resin doesn't leave your facility, but it's critical to implement those preventative measures and use these tools in conjunction with each other to make sure we are able to work towards that zero plastic resin loss. So that's it for my presentation. With that, I'll turn it over to you, Darren, and I'll take any questions.
Thank you very much, Neil. All right, just to round off, we've got Nicole Newton from the City of Calgary who would just like to talk about some of the regulatory process around getting LittaTraps installed. Neil, if you could just unshare. Yep, wonderful. Thank you. Cool. We've got you there, Nicole.
Can you see my presentation?
Yes, we've got it. Thanks.
Okay. Hi, everyone. I wanted to thank Darren and Greg and Stacy for inviting me to present at this session. So far, the information I've heard has been very informative and encouraging to hear. And Neil, you touched on a lot of things that I know we've had long conversations about in terms of some of the concerns in the Calgary setting, for sure. So my name is Nicole Newton. I'm the leader monitoring compliance. I lead 3 teams here at the city in the water utility, responsible for enforcing the wastewater and stormwater bylaws. And I'm just going to share a quick overview of the stormwater regulations and share with the people on the call the approval process under our bylaw in terms of applying to have a LittaTrap or an inlet control device installed into their stormwater system. I have a feeling there's going to be a delay on this. Sorry, I just can't advance the slide.
If you click on the bottom left, there should be a little arrow that appears.
There you go.
Oh, there you go.
So just to give you a quick overview, my team's been conducting a regular compliance inspection program since some of the releases that Stacey had spoke about earlier. And our inspection program continues to suggest that there's still a bit of a systematic issue. A big piece of that relies around just the awareness of the stormwater system here in Calgary. We have a separate system, so anything that enters our stormwater system in Calgary does not go to the wastewater treatment plants. It actually goes directly to the river. In some city or in some neighborhoods, there are stormwater ponds between the stormwater system and the river that try to capture some of these things, but they're quite expensive to clean out as well. But just an awareness that basically anything that goes down the drain will likely end up directly in the river. And we still continue to notice some challenges in the shipping and receiving areas, and I know Neil had touched on that a little bit as well. Just that it is kind of one of the main areas to start implementing some BMPs. We do see a range of best management practices implemented through the OCS program, as well as just not members and non-members. But the focus really should be at the source. And any of those BMPs still require active monitoring, so it's not a one and done kind of situation. And my team continues to actively manage this under the stormwater bylaw, and we're monitoring the industry closely and tracking some of the compliance and working with businesses on both ends of the spectrum, trying to take lessons learned from the businesses that have been successful and work with some of the more challenging ones. So just to share an update, in 2021, Council had actually passed some revisions to our stormwater bylaw. And so under there, it states that no person shall release or allow to be released any prohibited material into the stormwater system. And now earlier on, what a prohibited material was a bit more broader. And Council has decided to specifically mention industrial plastics, including plastic pellets, flakes, or powder. So with that being a prohibited substance, I would say technically the tolerance is 0 entering the system. My team has started to work on some more education materials to address any kind of business, not specifically the plastic industry, but just industrial, commercial, and institutional businesses as a whole, in creating some awareness around what some of those practices might be. With a focus on minimizing exposure, encouraging clean and tidy sites, finding ways to manage runoff in some situations. In others, there is some challenges with erosion and sediment control, which can, if you have a large soil loss in unpaved areas, as Neil had talked about, it can also be a way of mobilizing some of the pellets. Focus on prevention and preparation for spills. So if you do have a spills, accidents do happen. What is your procedure and response for that? And having ongoing inspection and maintenance programs. So these are just some of the things that we're starting to promote through our ICI, Industrial, Commercial, and Institutional program. Just wanted to share a few quick photos similar to what Neil had shared. These are just some of the BMPs that we see in place. So there are some, bins in the rail yards, collecting these, loading and offloading, and just making some of the tools for quick cleanup visible and accessible to employees really helps. So diving a little bit more down into inlet protection, there are various types of inlet protection, and the LittaTrap is certainly one that is garnering a little bit more attention and has kind of helped prompt a bit more of a formal process in how to install or how to gain approval for this. So in the last, just over the summer, my team has kind of put together a guideline document for obtaining approval at ICI facilities. And I'm just going to talk through that. So just to recap the stormwater bylaw. So no one is actually permitted to, under the bylaw, it states that no one's permitted to install an inlet protection device within any part of the stormwater system, whether it's public or private, without prior approval of the city. And one of the main reasons for that is an opportunity for us to evaluate if the installation, depending on the type of device, might cause some hydraulic issues that could maybe cause neighbor to neighbor flooding or flooding into public spaces, which starts to raise a safety and liability concern for the city. In most cases, such devices are not permitted to be installed within any storm manhole or catch basin in the city right away. So on the public side of the infrastructure, it's not a best practice that we like to promote, just given the operation and maintenance requirements, and again, some of those public safety risks that might arise. But there are, again, situations where it's required. However, devices may be permitted on a case-by-case basis for use within the private system at an ICI facility. And as I mentioned before, just these inlet protection devices can cause risk of stormwater backup, localized flooding, and typically must be designed with an overflow system that cannot interfere with the stormwater. And I do know that in the pilot case that had taken place, that the overflow system was demobilized, but it was for a specific reason, and that would be something that would be taken under consideration depending on what the objective for installing it would be. So just to give a quick overview for the procedure for requesting approval, and this is specific to Calgary, we've just set up that a request for people to submit to the Stormwater Pollution Prevention email address, so stmpp@calgary.ca, with a specific subject line to request to install an inlet protection. And just to clarify, there's actually a one-pager that will be posted on our City of Calgary website, calgary.ca/ESC. After this, I was hoping it would be up for the presentation, but it hasn't made its way there yet. So, but you'll have this information after regardless. So what happens once that request comes in is my team will review the request. And we would generate a 311 service request. And you should get a response from the team within 3 to 5 days, as Darren had mentioned earlier. And then that application process will start, and it would take potentially up to 14 business days. And then the applicant would be notified of the outcome. So we might be asking for some additional information. We may request for an inspector to come on site to do a quick inspection for some pre-approvals. There, just depending on some of the information we have, there might be a rejection of the application. But at the end, you would receive an approval letter before installing that device. And just to provide some additional information in terms of what information should be included in that email, we would be looking for basically the information that needs to be put into our approval. So your contact information, phone number, and the person responsible. So it's typically the facility owner or operator. A brief description of your operations and the waste or material to be captured. So in this case, it would be plastic pellets. A description of other pollutant sources and what controls are being implemented. And the detail of the purpose that you're looking, or of the device that you're looking to install. And again, in this case, I'm guessing it's the LittaTrap piece. And so we would be looking for some manufacturer information as part of that. I just wanted to reiterate, as Neil had already said, so I'm glad we're speaking the same language, that the inlet protection is your last line of defense. And if you start to see plastic pellets in these, I know the expectation of zero is very challenging, but it does start to give some indications that maybe some of your upstream BMPs may need to be revisited. So just a heads up to kind of keep an eye on that. So there might be other things in terms of sediment buildup that's plugging the system, or there's some breakdown that's taking place if you're using other inlet devices, or in the case of the LittaTrap, maybe there's pardon me, some other maintenance or increased maintenance that needs to take place. But at the end of the day, like, we're all trying to work together for that goal of zero. And with that, I will leave it open to any questions.
Thank you very much, Nicole. If I can just share my last slide here. Okay, so first of all, thank you very much to everyone that attended and to all the speakers. Just in terms of sales-related inquiries, I mentioned our North American sales manager is Will Harris. You can get him on his email address or on his toll-free phone number. If anybody's got any technical questions, you're welcome to contact myself.